Thank you very much, everyone who invited me. Pygrunn was amazing, and I'm happy to be here as well. I actually, this is only 25 minutes, and that's not a lot. It's not enough for me, as my wife would tell you. So I'm going to be very quick, and I'm going to run. And there's a feature on YouTube. You can slow it down later if you want. And if you have questions, keep them to the end. So we're going to go about who am I? Data version. But wait, why? Okay, cool. But how? Makes sense? Thank you. So a bit about me. I've been doing machine learning for about 10 years. I've been a founder engineer in about 4 different startups, and I'm a developer advocate for ZDAB. I'm also an incredible salsa dancer. If you girls here know how to dance, you should later. Okay. I'll start with one question to you guys, and I expect you to raise your hands. Who here works with Git? Who here never heard of Git? Good, because for those guys, this is going to be a very difficult talk. So the problem in Git in general, when we work, and this is all in the context of machine learning. This is incredible, because it's just between me and the screen. That let's say you're working with any kind of a big file, let's say a movie file that you try to work with and you cut it and edit it. If you work with Git, every time you're saving a copy, Git saves an entire history of that file. That means that if you, let's say, just trim it by a bit, you actually keep the history, you keep another complete file. And therefore, if you do a lot of changes to a big file, your boss tries to clone your repo and it explodes. Now, in reality, you don't get to that point because Git tells you, no, that's not a thing. You can't use this big file, which is a shame because we are machine learning engineers. We love to save models and data and a lot of other things, and we can't do it. So what do? And the people who do use machine learning here knows. You go and you get a blob store, a place that is very resilient and very cheap, and you can upload data there, and you can invent a lot of funny names for all of your buckets, and you just put all your assets over there. So let's say you're a machine learning engineer in a company, you have a bunch of projects that company does, and each project might have a few different environments, and each environment might have all kind of stages of the data. And when you build a model, you might build different models for different stages, and for those models, you might make multiple experiments. And for the model, when it goes to production, you all want to monitor on what each model did if it was in production, and also you have other logs that your app can do, and some other assets that your app might be related, and your model might need to interact with, and it can get out of hand. So on top of that wonderful aspect, there is a lot of relationship between all of these different addresses that you have to remember. So I have a model in production, but which code, which parameters did I use? What data was it trained off? Can I train it again, but without Frisian people? That model, where is the monitoring data for that one? How does it do? Which parameters did well, which parameter did for which model in the which we are monitoring. If I want to revert, which one do I revert to and how do I do it? Now, there's a lot of relationship between all of those addresses and buckets that we saw earlier. And this is not to make fun of everyone. This is an actual standard normal solution. You put all your code for your project, the training and prediction code and inference code, you put it in one place, and then you save the model over there, and then you do a backup over there. And if you do experiments, you maybe do it on a different projects, and then you save all the models. And in big companies, when you train a model, you also make a snapshot of the data of that moment. So if the regulator will come later and go like, hey, did you do this thing which we do not accept anymore? And you go like, I don't remember. Then you need to find which data you trained and then check it out and then do adjustment and retrain. So big companies also have copies and snapshots of the entire data set they use for each model that they're making. And the results, the models, you need to save them someplace, and then you need to manage which one goes into production, and then you have the monitoring data, which goes to a different bucket, and then you have another project where you download that data, and you kind of try to figure out everything, and everything just managed in config files, and you just do it. You just figure it out, which makes you sad. Every image here is generated by AI and took me very little time to do. So there are going to be a lot of misspelling. So what is data versioning? It's this. You go like git checkout, and everything you need is just there. The logs for your model, the monitoring that you have, the experiments you've done, the code that run the model that you are now checking out. Everything is just local, and it's nice, and it's organized, and you just have it there. You don't need to download and upload and manage and all the config things. You just check out. Look at this guy. Okay, but how? And this is going to be a bit more complicated, but it's not insanely complicated, I would argue. So I made this article, and if you squint, you can find it online. And if you squint, you can see that I edited it to look like I had 2.4 million claps. And there is also a demo which I'll share with you at the end, where you can just try everything. There is a CLI with documentation. You can just run and play and just try everything and see how it looks like, and then go to the code and see how everything was done. And specifically for this demo, I use MLflow for machine learning tracking. Who here knows, heard, used MLflow? Raise your hands. So MLflow is a very popular solution for experiment tracking, but there are other ones, and most of them work the same. You either put everything, you throw it to someone else's cloud, or you're getting out a file or a bunch of files, and then it applies in the same way. So what we're going to use to make all of it happen is we're going to use branches. We rely on the fact that data versioning just let us put our data into Git, and we're going to use branches in a bit more sophisticated way to kind of manage everything we saw before, and tags. Now, if you experience with Git, you definitely know what the branches is. Every time you commit, there is a label of that branch that moves with you. And tags is a version of it that doesn't move. So if you tag a specific commit, it stays there forever. Well, you can delete it, but it stays there forever even if you delete that branch. You can always get, it's like a snapshot of everything together. And I'm diving right in. If you have any questions, no questions, great. I didn't give you time to raise your hands. So the first branch is the main. And the main here is actually not going to be used in the standard way that we normally use it, where we just trunk all our code there. We're actually going to use it as a landing page. And it's very important when you do a new project to always start with clarifying the business problems and what are the target values, how you obtain them, what type of evaluations you're going to use, and why. And this is the place, other requirements you have. This is the place where you collaborate. You can put your wikis. When someone wants to see what's going on, that's where they go. It's kind of the landing page, the place where everything comes together. But actually, we're not going to use it for code at all. In this case, I took, for this demo, it's the diabetes data set, so you can have a README. I put a bunch of what the data is, how it was obtained, what metrics, and a bunch of other things, and a small kind of distribution of the values. And if you just go to the main, you kind of figure out what we're talking about. And it gives you an introduction. That's where you're going to put all the docs for your packages and architectures and so on. Now we get a bit to the more meat part of it, which is data branches. Now, earlier we had our buckets, we had our assets on remote, and they're still going to be in a kind of resilient, place outside in the cloud, somewhere that we can rely on cheaply. But we're just going to manage it with branches. So what you do, you just turn it into branches. So you check out a raw branch, and then you upload the data there, and you can check out from the raw a split branch, and you can pull data around. And if, for example, I want to use something like automations that I want to, for example, split it in a random way, I can make an automation that whenever data goes to raw, I split it in the way that I want to split it, and then move it into the split branch. So this is just managing what we had before. It just put us everything together in a way that makes sense for us. And it takes all kind of those elaborated addresses that we would use initially, where you kind of figure everything out through the address, and you just like check out the branch or the label, and you just get the data there. So, and also branches are free. So if you want to create different environment or different buckets, it's very, very, you don't use the buckets, you use more branches. And if you have the same file in multiple branches, all data versioning tools, they do something called file duplication. That means that you don't pay for it twice. So if you take a file and I branch out, and now I have another branch with the same file, behind the scene is just a pointer to the same file. And more sophisticated solutions like ZApp do a chunk deduplication, where even if you do a small chunk, then you have links to all the chunks. So even like appending more columns with feature engineering or appending rows you don't pay for. So, but almost everything we talk about here can work with multiple data versioning tools. So don't worry about it. One tip, always upload to raw. So this is really nice. Whenever you get new files, new data, you upload it to raw. You never delete it from raw. And then whatever happens, you can always kind of figure out what happened. You can revert it. You do one split, you can do another split and start your automation from a different point. You can always figure out what's going on, and it gives you a lot of confidence. I don't know how many of you have worked with files, and then you have like a CSV, and you made a processed version, and then you're like, okay, I'm just going to copy it to my desktop, and I'm going to work, and then I'm going to copy it back because I made a mistake. Or like you're very worried about what will happen to it. But in this way, you just work, you delete, revert, easy peasy, the same you do with code. This is how it actually looks like in practice. You either git out, like in this example, all the data I put in a data folder and I just check out that data. And if someone uploaded more data, then it will just appear for me locally. And it can save you a lot of troubles. Nevertheless, I think it's very often much better to use a CLI. Zeta, DVC, they all have like other tools. They have CLI tools like copy, where you can copy data around, and that's a bit more robust, but it depends on your use case. At the end of the day, if you look at the demo, which I still don't think I will have time for it, then it's just going to be add data and data split, and then you can check it out and see how it works behind the scene. But at the end of the day, it just helps you figure out what is the latest version of the data or the version that works with the model you're working at the moment. You could do it with a database. You can go like, oh, the last file was on this date. Which new data do I have? And then I export it and kind of try to figure it out. But in reality, in machine learning, you don't want to work too much with databases because they are mostly doing other things in production. And exporting of a lot of data is very expensive. So almost always you ended up having a lot of files. So this system works very well to kind of be on top of it and create easy to manage cycles. Development branches is where you write all of your normal code. This is like the standard place where you code and you have both your data and your code. So you have an active branch, which is kind of like a trunk branch. If you know trunk-based development, it means that one never dies. You keep it, you don't delete it, and you just keep merging things into that branch. And I like to have one like dev model, and that model is the last version before it goes into production. And then you can create one model, like let's say a baseline, and another one that is a linear regression, and so on, and then you merge them into the dev one. Those are like normal feature branches. This is very standard Git type development, and you can also delete those when you're done. Now there is an inherent, well, not inherent, but there is another implementation here, a best practice to do, which is when you implement a project at the beginning, you start with a very simple baseline model. If it's a regression, you just put the mean or the median. If it's a classification, you just put the most popular one. And then you develop it, you put it in kind of like, you send it into development to the rest of your team so they can start working on it. You can start already getting some of the requirements out and see all the miscommunication you're going to have. And sometimes that model is just good enough to start with and get feedback from your audience as well. So it's very good to start with the baseline thing, not to sit too much on it, and then move like to a simpler model and then build more and more complicated models. Now, only code in dev. This is a senior cat, and it's his advice. You want to make sure that you don't go to kind of production, like kind of you wouldn't want to write code in main. You don't want to write code in prod and in other branches. You want to code always in dev. So you go to dev, and then you put the code back there. Now, this is where tags kind of come along, where you feel very comfortable with a version. This is my baseline, all the tests pass, I think it's good. You tag it. And now you know that you have a snapshot of the data, of everything you need. You don't need to do any other changes, and this will keep forever. So even if I delete the dev baseline branch later, and afterwards I'm like, wait, the baseline, was it a mean or the median. You just check out you can't see it, but it says, or maybe you can. Oh, you can't. It's dev baseline.1, and then you can just check it out and see exactly what you did. Another benefit of this, and I had some jokes of Aryan here, but I didn't see him initially, so I hide those slides. But is about maintaining data sets that are processed in the middle. So this is, in this example, and all of it is in the demo, it's specifically meant to give examples of a lot of best practices. You can, for example, run a PCA, and then you just add and commit the PCA data, so the component data. So when you try to build new model, like move to XGBoost, you don't have to rerun the processing, you don't need to upload and download. You can maintain that intermediary state of your data. So let's say I start in the baseline, I get the raw data, then I write the code that does the pre-processing, and at the end, I now overwrite it. And for example, in the demo, I have a train, validation, and test. I use the train and validation to optimize the number of components, which is silly, but, well, you could do it, but I did it just so I can, at the end, merge the versions, the train and validation together, and delete the validation file. So if you now check out one of the later models, you just have train and test, and they are already at PCA. You don't deal with anything that came before it. You don't need to have extra files just in case. You can always retrieve them if you want to. Now, stable branches are kind of like our prod version of it, is where you kind of, and they don't do any code, but they still run. So you can imagine that your server is kind of like checkout prod, or checkout prod.1, the tag of it, and then it pulls the data, and you can retrain. You automatically can kind of get this system when you can retrain your model very easily. Oh, we're good with time. Thank you, Berko. You pull the data, and then you run the training, you run your tests, and if everything is okay, you kind of upload everything to the cloud. And upload is just committing it, pushing it, and tag it. And here in this example, this is how the demo would look like. Again, I didn't know if we'll have time to run it, but it just check if we should upload data. And then it sees that it's nice, it's training the model, it passes the test, and those tests are just the same tests I do when I develop all my code. It's just my normal PyTest. I just run them as part of the flow, and if everything is okay, I upload the experiment results to the cloud, and I tag that commit, so now I always have that snapshot with the data, with the code, with everything that MLflow is also saving, or any other experiment tracking. So MLflow, here you can see it saves like an experiment slash, it creates an MLrun folder, and then it makes an experiment slash the run specific one, and then it has all the metrics, the accuracy, the precision, all the stuff you want, which parameters you use, all of it is saved there, and it goes with it, so you can always find it later. So this is a small hack, because this lets me, in any branch, I can check if the split branch, that's the last one where I will see any last version of my data, if it had any changes. So when I build a model, I keep which was the latest version, the commit that the data had, and I save it later, and later on, if I want to retrain, I check, do I need to download the data again? And if not, I don't. Okay, here there was another joke about Aryan. Which is about how you can use the unit test. It's all from your video that you gave last week. It's your fault for not saying hello to me. And a last reminder, this is another senior cat. Don't fix problems in prod. If prod crashes, you check out dev, you fix it there, and you send it back to prod. This will kind of make sure that your snapshots and all your data and all your MLflow information, everything is kind of set up. You don't want to work on prod, but you can use it to kind of debug or for experiment tracking and so on. So there was another joke on you here, but it was the last one, about logging everything you do. And who here has done some model monitoring in production? So this is nice. This is actually something that you don't get to very often, because it's kind of a nice to have in most cases. So one nice way to do it is whenever you get a prediction to your server, you save all the different values that you got, and you save the predictions that you had. And I like to also save a lot of the metadata of that model. And that kind of goes, again, and I just commit it back to the cloud. And one of the things that I'm a big fan of is to also save that tag. The end result of it is that I can take that information, and in the monitoring branch, I can write alerts, I can do analysis and see that I have data drifts, and if there is a data drift, every time I can pull the data, it's the new monitoring data that that the server uploaded, and then I can check out if there is a drift, I can deal with it, I can see which model has it, I can go back to the ML flow and see all the parameters and all the information that I want. And at any given moment, if I want to debug and understand what's going on, I just go like, this model, what it does, check out prod 3. And I have it. I have everything there. I can see all the parameters, the metrics, the evaluation. I can compare everything together and see if it's what I would expect. This is how ML flow looks like when you run kind of an ML flow UI. And because I have the tag as part of the parameters, I can actually just compare those tags and see which model does better. And it's a very good mapping of this model in production is exactly this type of parameters and the accuracy and all the other metrics that I want to have. Now, it's kind of early in the morning and it's a very fast talk. Oh, we're good. And it's a fast talk, but you might think, wait, but how do you only tag it after you upload it, so how could you know the parameters of the tag before you tag it? And the thing is, you just check out. So you can just go, when you're training, I'm going to prod and I check what is the latest tag. I know that I'm on prod, so I check prod.1, prod.2, next one should be prod.3. And then I figure it out before I tagged it, I already added it as a parameter. And that kind of make everything connected with a tag because it's going to be part of the monitoring, it's going to be part of the parameters of the models. And if the tests don't pass, it won't go into the cloud. And you definitely won't see it on the monitoring because there is no server with these predictions with that tag because the PyTest failed. So that kind of put everything in place and kind of stick everything together. And the last branch that we want to talk about is the analysis branch. And again, in many projects, it's just a different project. You just open a new GitHub and you go to a different place and you have a different buckets for it. And then you go and you again take the data or you drag it from one project to another on your laptop if the data is small enough. And you don't have to do it. You just check out for monitoring and you make an analysis branch. And that's a very easy way to have everything connected. You can also take the data, raw data, or data from other sides of your organization. You put everything on the analysis, and then you have a data scientist. He can look at everything, he can work. And it makes a lot of kind of comparison and gets you the data and the models, everything kind of together in one place you can work with. Now, again, another small tip is a few classic experiments that you can do is something like a forward test, where if you have two models and you think one of them should be better because that's what we saw on our experiment tracking, then you give it to 1% of your audience, and then the last 99 is what you had at the moment, and you see that you get something like what you expected. And another thing that is a cool trick is after you're happy with it, you switch it around and you make sure you kind of get now the reverse effect. And that kind of ensures that you got the effect because of the model and not other things. And if you don't, you know where to go and to check what happened. And of course, you can do other type of offline analysis, for example, comparing those models and see which one is better and so on. So this is the demo, and I'm going to give you questions, and then if we are happy, I'm just going to run it, and hopefully everything is going to work. There is the daemon of demos that doesn't let any demo work. We're going to see. But in general, that's how it looks like. You go like demo help, and then you see all these options. And if you want, this is the QR to get it. I don't see any phones. That means you're really asleep. It's good. You know what? We can do it. Do you have faith? Okay. That's good. So this is how it looks like if you check out. And I wonder if I have internet. Do I have internet? We'll see. So you can train it, and if you want to, you can go something like, you can serve any of the models you want. So I can do, now we can see if we have the tag. So what was the last model? Let's say do this one. And what it does, this is a bit an extra sophisticated the way that it does it, because it takes and clones just the relevant parts and it lazily load in the models. And we'll see if it works. That means that I do have internet. Okay, and I'm not sure I have internet, which is a classic demo thingy. Hmm? No, I know, but I'm just gonna do it offline. So this is offline, so it just run the local code, and this is how it's gonna look like. It's just a server. By the way, I inserted a lot of like best practices. So, and again, I'm too lazy to run curl, so I like run this curl for me 50 times. That should work. Yeah, just runs it. And you can see it will sync the monitor on every few seconds. This is probably not going to work because of the internet. But the point behind it is that if you want an example of how to deploy a machine learning model, you can also use that demo. If you want to see how to sync kind of your monitoring behind the scene, this is another good example. Oh, it did sync it. Oh, that's really nice. And then if you want to see kind of what it did, then you can do like the latest, and you can see kind of what the latest model just did. So you can see the monitoring, and it's prod 8 because last night I wasn't sure, so I trained it again and again and again to make sure it's going to work today. And you can see kind of the ML runs, and you can find all the other metrics. Let's see, we have 30, 3D. So this is how it looks like. And under the metrics, we can see how it did. So that's how the project looks like, and we actually can, because we have the time, look at the actual code of it. And I made it the way Aryan likes, but again, I want to make fun of him, so I then change everything to object-oriented. But so you just have like, most of it is just the main. A lot of the complexity we saw earlier is just like 1 or 2 lines of code. There is nothing too sophisticated here. The training code is very condensed because I wanted to have one file where you can find all the things you need, but it's a good example of how to kind of put a predictor online and so on, and just a fast API app. Again, not too clever. Another tip I like to do is I like to use transform in production. So predict, normally in machine learning, it gives you just the prediction. So if you have a model, it gives you 0 or 1 or whatever, and transform kind of give you a bunch of new columns. And because I like to put a lot of different metadata into my predictions, I use transform, and then I get all the data, and I add a column of the prediction, a column of the time that it took, the time that I did it, the model, and so on. And then I return just whatever I want to return. Okay, I'll go over what we did, and then we have questions. So we went over in this pretty fast talk about how we use normal Git, the tool that all of you raise their hands when I ask if you use it. And you just use that one to kind of manage all your data. So if you're struggling to kind of track after everything and you find yourself copy things to your desktop and try to figure those things out, this is how version control can work. It's not a very new tool, but it's still just gaining popularity. There's still a lot of room to growth of how to use it and build best practices and kind of familiarize yourself with it. So we had the main, we had the data branches, which you can use in many different creative ways. Then you write all your code in feature branches and in active trunk branch like a dev one. And you can have different prod one or a candidate one, and you can use those kind of places where you don't code because you don't want to mess with the senior cat. And at the end of it, you can, again, you put your data into a branch of monitoring instead of a bucket of monitoring. And you develop it on a dev monitoring, and then you can merge it and run all kind of your alerts and automations and so on. Any questions?
Thank you. There's a microphone here. Are there any questions? Yeah.
Aye.
and stuff connected or integrated with Git, or is that just commands that you run locally to get those files? Or am I completely misunderstanding
No, there are three different aspects that I want to address. One of them, that Git and GitHub are not the same thing. So Git is a set of tools, that, but you can use it with GitHub, with ZetHub, with GitLab, with Bitbuckets. Those are all remote platforms for Git. Now, DVC is a good example of something that works very well with all of them. And ZetHub works currently with GitHub, so you can, it's like an app, you sign in and then all of your files are behind the scene managed with ZetHub, or you can use it as is, instead of GitHub. And yeah, you can use those ones. Another very common one is LFS. LFS is a bit more of a thing to manage. It's famous, but it's a bit more work and it has some challenges. It doesn't have as intensive CLI as the rest of them. And maybe this is a good point to talk about, or to mention data lakes with Git powers. That's also a thing. It's kind of like a middleware between your code and S3 or your bucket, but it doesn't integrate with your code. So data lakes that have Git is just a place where you can save all your data and do Git actions on it, but your code is there and your Git is there, but you have a lot of Git capabilities on your data. So those are Git data lakes and data versioning tools.